and one Visa gift card. And if you add 15 to 20, it's 35, which just gets rid of one.
Exactly. So Tiffany's gift was $20 and one Visa gift card, and then Todd's was $35 and 2 Visa gift cards. So Todd got $35 or $15 more cash than Tiffany, right? But then Tiffany got one, huh? Thank you. I was like, wait a minute, that's not working out, right? Tiffany was $20 and 2 gift cards. Thank you. Oh. And Todd was 35 and 1. That's right. And the grandma told us that they're equal, right? So numbers 1 and 2 are kind of just like trick questions. But again, just like Taylor said, so Todd received $15 more than Tiffany, but Tiffany received 1 gift card more, right? So then that means that one gift card has to be $15 if the 2 gifts are equal. So can you guys try number 4? It's kind of the same deal. Tiffany gets $25, this time a box of candy. So try and write a little expression for that. And then Todd got $20 and 5 boxes of candy. So write an expression for that as well and see if you can figure out how much each box of candy is. How do I write $25 on a box of candy? Good. So again, we look at kind of the difference between our constant terms and our variable terms, between the cash and the boxes of candy. So how much more money did Tiffany get than Todd? $5 more. And how many more boxes of candy did Todd get than Tiffany? 4 more. So that tells me that those 4 boxes of candy are worth $5. So then how am I going to figure out what X is? Divide by 4 on both sides, right, which cancels out this 4. And so what does X equal? Good. Exactly, $1.25. Okay. Let's try 5. How am I going to write down Tiffany's gift? She got $15 and 2 pairs of socks this time. Good. 15 plus 2x. And what about Todd? Good. 10 plus 2x. Okay, and this time we're checking to see, is it possible that these 2 things are equal to each other? So how much more money did Tiffany get than Todd? $5 more. And how many more socks did Todd get than Tiffany? No more, right? 0. So is that possible? Is 0 ever going to be equal to 5? No.
I mean, well, technically, she could have bought 2 pairs of, like,
more expensive socks.
Yeah.
True. It doesn't say anything about that. So that's the only way that it's possible, though. If the socks are the same, then there's no way that the gifts are going to be equal to each other, right? It doesn't say anything about the price of the socks. So you're right. Yeah. Okay. Can we flip? We'll stay on the same side of the paper, but we're going to do the other half. And this is stuff that we learned last semester. We've done this all already, but it relates to what we're going to learn about today. So we're going to do a few problems over here on this side to just kind of warm up, and then we'll look at the other side. Okay. So in number 1, it tells me to look at this equation, negative 4x plus 11 equals negative 10x plus 17. And I want to compare the value of the variable terms. What are my variable terms in this equation? What are the variable terms? X is the variable, yes, but what are the variable terms? Negative 4x and negative 10x. So I want to compare the value. That means not just say like, oh, that's negative 4 and that's negative 10. And what's the difference between them? How would I get from negative 4 to negative 10? What would I need to do? Yeah, I'd have to subtract 6. Subtract 6, but not just subtract 6, subtract 6x. Okay, and then what are my constant terms? 11 and 17. How am I going to go from 11 or 17 to 11? How do I go from 17 to 11? From 17 to 11. Yeah, subtract 6. So that means when I have variables on both sides of the equation like this, I can compare those variable terms and compare the constant terms, and then I can set those two things equal to one another. Negative 6x equals negative 6. And then how do I solve for x? Divide by negative 6 on both sides, which cancels out those 6's. So x equals what? 1. Okay. There's other ways to solve these kind of equations. You can do this as well. So I can move my variable terms all to the same side. So I'd end up right by, you don't have to copy this down if you don't want to. But I end up with 11 equals negative 6x plus 17, and then minus 17, minus 17. And look at that, I end up at negative 6 equals negative 6x. So I can do it this way, but it's just like extra steps. This is just kind of a shortcut. Does that make sense? Okay. It gets me to the same exact answer, right? I'm still going to get x equals 1. Okay. I like this just because it kind of simplifies it a little bit. Okay, I want you guys to try number 2. Try number 2. Start by looking at your variable terms. Compare your variable terms, and then compare the constant terms. And I think about it kind of going around in a circle. So I look left to right. How am I going to get from this to this? And then I go right to left. How do I get from this to that? And those two things are equal to each other. The difference in the variable terms is always made up for in the difference in the constant terms. How do I go from 4x to 6x plus 2x? And how do I go from 2 to 10? So that tells me then that 2x equals 8. And then how do I solve for x? Divide by 2. And so x equals 4. Perfect. Okay. All right. Now let's look at number 3. So in number 3, they're talking about company A and company B. Company A has 61 employees and is hiring 5 employees per year. Company B currently has 7 employees and is hiring 11 per year. I'm going to write 2 different equations, and I'm going to write both of those equations in slope-intercept form. So what are the 2 letters I need to replace with numbers? M and B. And what is M? What does M tell us though? Yeah, it's the slope or the rate. And what is B? The y-intercept? Yeah, it's that starting point. Okay, so for company A, what is the rate for company A? Yeah, so 5x, right? 5x. 5 employees for every year that they're open. And then what's the starting point for company A? Yeah, 61, right? Okay, and then what about company B? What's the rate? 11. So 11x, and then what's the starting amount? 7. Okay. So what I'm trying to figure out is how many years it's going to take for the two different companies to have the same amount of employees. So when the pink Y is going to equal the purple Y. And this is going to equal this. So in other words, it's when 5x plus 61 equals 11x plus 7. And do you see how this is exactly like the other problems we've been doing? We've got variables on both sides of the equal sign. So we can do the same thing. I can compare my variable terms and compare my constant terms. So what's the difference between the variable terms? 6. X, right? 6x. Oh, yeah, it's okay. And then what's the difference between my constant terms? Good, 54. So then that tells me that 6x equals 54. And then how do I solve for x? Divide by 6. And what does x equal? 9.
Oh, I still have it right.
Good. What did you do? Did you just test it out?
I did like negative. So
Huh?
I did negative.
Oh, that's okay. Yeah, I had someone who just plugged in 61 and then kept adding 5 and then 7 and kept adding 11. Yeah, that's fine. That's a perfectly fine way to solve a problem, but this was a little more efficient, wasn't it? Yeah. Okay, let's look at the other side of the paper and I'm going to show you what we're doing today. So, we have been talking about systems of equations. Systems of equations. That means more than one equation, right? And how were we solving our systems of equations last week? With a graph. So, right, I was like given a coordinate plane and I would look at my first equation and I'd plot the y-intercept and then I'd use my slope to draw the line, right? And then I'd look at my second line and look at the y-intercept, and then I'd use my slope to draw the line, and then what would I do once I drew both of my lines? Find the intersection. And how are you supposed to tell me what the intersection is? Yeah, x comma y, right? X comma y. Okay. So today what we're going to do is we're not going to be using a graph, right? There's no graphs on here. I don't need to use a graph to do this anymore. What I'm going to do is I'm going to figure out when this y is equal to that y. When this top equation is equal to the bottom equation. And negative 4x plus 4 equals x minus 1. And again, do you see how this is the exact same type of problem you had on the other side? So again, we can compare our variable terms and compare our constant terms. So let's think about how am I going to get from x to negative 4? X to negative 4, and that's a 1x, right? So how do I go from 1 down to negative 4? You're definitely going to subtract. Good, subtract 5, right? I go down to 0, negative 1, negative 2, negative 3. If you have issues with your negative numbers and stuff, it really helps to draw a little number line. You can try that. Okay, so to go from 1x to negative 4x, I needed to subtract 5x. Oops. Negative 5x. Negative 5x. And then how do I go from 4 down to negative 1? Yeah, subtract 5 again. Right? 4 to negative 1, I'm also subtracting 5. So then negative 5x equals negative 5, and then how do I solve for x? Divide by negative 5. Very good. So then those cancel, and I get x is equal to 1. Okay? But you told me that my answer needs to be not just x, it needs to be x and y. So if my x is 1, how am I going to figure out what y is? How would you know that? No, that's not quite right. You are actually right though that it is 0, but that's just a coincidence. How are we going to figure out what y is? There's no y. I see 2 y's right here. 1, 2. How am I going to figure out what y is? It's just whatever is next to y. There's nothing next to y. An equal sign? What do you mean solve it? Solve it for what though? Negative 4x plus 4. It's already solved for y. What? No. Do you want me to tell you, or do you want to try and figure it out? With negative 1? I am going to use this information that x is 1. So if I know x is 1, I can plug in 1 for the x.
Oh.
So then y equals negative 4 times 1 plus 4. So what's negative 4 times 1 is negative 4. And what's negative 4 plus 4? It's 0. So that's my y coordinate. So I take it and I plug it back in. And I could have used either equation. Just you guys said that top equation, so that's what I used. But you can use either one, right? If I were to plug in 1 for this x, I'd still end up with 0. 1 minus 1 is 0, right? Let's try number 3 together. Let's get 3. So again, I'm trying to figure out when this top y is going to equal the bottom y. So in other words, I need to figure out when 2x minus 4 is equal to 4x minus 10. And again, when I have variables on both sides of the equal sign like this, I can compare my variable terms and compare my constant terms and set those equal to each other. So 2x to 4x, what's the difference? Yeah, I'm going to add 2x to get there. And what about negative 10 to negative 4? Good. Negative 10 to negative 4. I'm going to go up 6. 9, 8, 7, 6, 5. Go up 6. So then that tells me 2x is equal to 6. And then how do I solve for x? Divide by 2, divide by 2. So what does x equal?
4.
Huh?
4? No, 3.
Good. Okay. Is that my whole answer? Am I done? No, that's just my x coordinate. Now I need to find my y coordinate. How am I going to find my y coordinate? Yeah, I'm going to plug in 3 for x, and it doesn't matter. I can use this equation or the bottom equation. Usually I pick the one that has the smaller numbers and the least amount of negative numbers because I just don't want to do that. Right? I want to pick the easier one. So I'll look at y equals 2x minus 4. But now that I know x is 3, I can plug in 3 for x. Yeah, good. Y equals 2 times 3, which is 6, and 6 minus 4 is 2. So y equals 2, so my answer is 3, 2, right? X and y coordinate. Do you guys want to see one more, or do you want to try it on your own? I'll come and talk to you about it. Okay. Yeah, I have a little kiosk set up now, so please use that. Did I? Yeah, a kiosk is just like you can have a human run kiosk as well, like at an amusement park. That's what I think about. There was a game when I was a kid called Roller Coaster Tycoon, and you would like build amusement parks and build roller coasters and stuff. And there was a kiosk, and that was just like where you go and like ask for information, or you buy a map or whatever. So you can have a kiosk like that, a kiosk like this, a kiosk at McDonald's. It's just kind of like a something you can like interact with, I guess. I don't know. I don't want to look up the definition of a kiosk now. Define kiosk.
Wait, so is number 2 gonna be like the socks one? Is like
No, but that's a good idea, but no. It says a small open-fronted hut or cubicle from which newspapers, refreshments, tickets, etc. are sold. Or a small structure in a public area used for providing information or displaying advertisements, often incorporating an interactive display screen or screens. So, there you go. So try number 2. I'm not number 2, number 5. I'm sorry. Number 5 is
doesn't matter what order you subtract things in, like the variables or
No, the only thing is that you kind of gotta, like, I think about it kind of going around in a circle. You gotta go like left to right and then right to left. If you do, right, if I did 2x, like 4x minus 2x is 2x, but then if I did negative 10 minus negative 4, that would be negative 6. And then I'd end up with the wrong sign. So you kind of gotta go like, And then we get the X by itself. Yeah. Mm-hmm. Good. Yes.
But you're adding which one? This one? And then 23 minus 19 is 4. And then 23 minus 4. Because
All right. Okay, so again, I'm trying to figure out when this y is going to equal this y. So when is negative 3x plus 19 going to equal negative 4x plus 23? And when I have variables on both sides of the equal sign, I can compare my variable terms and compare my constant terms. Thank you. So if I want to go from negative 3 to negative 4, what do I need to do? What's the difference between negative 3 and negative 4? Yeah, we're subtracting 1x. Some of you guys went the other way, which is fine, right? But because if you go negative 4 to negative 3, you're adding 1, right? But negative 3 to negative 4, I'm subtracting 1x. And then how do I go from 23 to 19?
No, you add?
23 to 19? If I have $23 but I want $19, how much do I have to spend?
Oh, shoot. No. Oh, yes.
Yes. 23 minus what gives you 19? 4. So that tells me negative 1x equals negative 4. And then how do I solve for x? So what does x equal?
4.
Positive 4. Okay, and that's half my answer. But now I need to find the y coordinate. How do I find the y coordinate? Doesn't matter which x I use, which one I use. It doesn't matter. So I'm going to use the one with the smaller numbers. Y equals negative 3x plus 19. But if I plug in 4 for x, yeah, what's negative 3 times 4? Good, negative 12. And what's negative 12 plus 19? 7. So that's my answer, 4, 7. Good job. Okay, let's do number 7 now too. Get number 7 done as well. Right. So again, for number 7, I'm looking to see where this y is going to equal my other y. So where negative 6x minus 23 equals negative 3x minus 11. And when I have variables on both sides, I can compare my variable terms, compare my constant terms. So how do I go from negative 6x to negative 3x? How am I gonna add or subtract to go from negative 6 to negative 3? We're gonna add how much? 3. And then from negative 11 to negative 23, am I gonna add or subtract? Subtract how much? 12. So then that tells me 3x equals negative 12. And then how do we solve for x? So then x equals negative 12 divided by 3. And again, that's half my answer. To figure out the other half, to figure out the y value, I need to plug it in to one of my equations. It doesn't matter which equation I pick, but I'm going to take that negative 4 and plug it in for the x. So then I get y equals -3 times -4 minus 11. What's -3 times -4? And then what's 12 minus 1? 1. So -4, 1. Okay. We're working on substitution all week long. Okay. So we will get more practice on this. Can you just hold on to those papers and then bring them back tomorrow? Because we'll finish working on them tomorrow. Okay.
I'm done.
You all done?
Yeah.
Okay. I'll check the rest tomorrow, okay?